I will answer your question with a statement that might not seem like an answer, but it is. The best compliment I think you can get as an economist PhD student, but also as a data scientist in tech, is that's a great question. Right? If someone says that's a great question, you should take it as a huge compliment because to me, most of the work in life, but especially in data science and ambiguous problems, is did you just ask the right question?
Colin, welcome. Super excited to have you. Do you want to introduce yourself?
Sure. My name's Colin Gray. I'm a principal economist at Wayfair. I started my sort of stats journey at MIT. I got a PhD in economics there, doing sort of causal inference on big data sets. I liked the day-to-day switching hats and the applied work in grad school. I kind of felt like I was on the sidelines, like we'd write a cool paper and then hope someone read it someday. So I joined tech. I went into Wayfair, which I think is a cool size because it's big enough to have scale, but small enough that you sort of know everybody. And you know that what you're doing is actually going to go somewhere. And I've been there for 4.5 years, so almost 5 years in the tech world. So thanks for having me.
And so what even got you interested in economics?
Yeah, that's sort of a long story, and I think it's common to a lot of economists. Ever since high school, I would sort of look around and be amazed by what humans did and what I couldn't do. So, like, if I look at my shirt, it's like amazing that we can make a shirt like that. It's amazing. My watch, I have an automatic watch, like a mechanical watch, just because I think it's incredible that we figured out how to do that. And then you get into things like planes or iPhones, like things that are way beyond what I could imagine. So I wanted to learn how it works, but what I realized is there's this meta question of how did we unlock that human potential in the first place? And when you get into concepts like how did we make money? Like how did we create trade? How do equity markets work? Like how did we just unlock all those expertise? That got a lot more meta. It was also underscored by the 2008 crisis where like no one understood what was happening, but and it was like vastly complex, but doing economics, you kind of get a handle on it, like how this system was breaking down. So I thought that was really fun. The stats also hooked me. Like I remember I didn't like math until I took real analysis when it was like, here's the structure of the universe. Here's how you find out whether things are true or not. Like it became a lot more meta. The core challenge of making sense of a noisy world was really interesting to me. There's something going on here that's bigger than me and my anecdotes. How do we collect like millions of anecdotes and figure out what's basically true or figure out a core mechanism? So I think that like starting from a big question of what's going on and then thinking in a practical applied world, how do we like make sense of noise and get out of our own anecdotes is what hooked me into econ and stats in particular.
So did you have this, I guess, aspiration to understand the world in this way when you entered the PhD?
I think so. I actually entered the PhD wanting to do macro, which I feel like a lot of people did because just the concept of monetary policy, like how we invented the concept of money and then run the whole world with it is really wild. I realized what split people in grad school was less the topic they came in interested in and maybe more their temperament, maybe. Macro people, especially at MIT, are very theoretical, and that's not bad. You need to be theoretical to understand a system like that. I really liked being able to translate a statistical concept into a graph, into English, and then go back into the technical side. And so things like public and labor and applied econometrics are a really good fit for that. So I sort of gravitated towards that just because the statistics kind of got me hooked.
And so I want to dive more into that, but I guess has doing economics satisfied your aspirations for understanding the world?
I don't think I'll ever satisfy my aspiration for understanding the world. I think it provides a good base. Maybe you feel this way too. I think if I read the news or if I read something about like global politics or the news or interest rates or the economy, like I have a base level to understand it. And that actually takes a little while. So I think on a day-to-day basis, like reading the newspaper, it's absolutely true that it helps. I think the thing it helps with more, which is not unique to economics, but I think is typical of applied math and statistics professions, is like thinking in a structured way to put together a problem. So I talk to my mechanical engineer friends and we use completely different language, but in the core, we're kind of doing a similar procedure in our heads. Operations research people, economics people, stats people, they all speak almost tangential languages. I think that process of like being able to put things together in a super structured way and thinking statistically is just super powerful in a given domain that you walk into.
Yeah, and I find it interesting what you say about speaking to your colleagues from different disciplines because I find especially with people who have done a PhD where you're basically trained during 6 years to be a problem solver, you apply that technical mathematical toolbox to solve a problem, but then you look for different things often.
I almost think there's a selection issue here too. Like, I know plenty of non-PhDs who can do this and do this very well. I know some PhDs who I think don't do this very well because they're so in the weeds that they don't step back and try to see the big picture. I think a lot of the reason that it's fun to talk to PhDs is because there's a selection of people who really wanted to see the big picture but get into the weeds and then zoom back out to the big picture that tend to do that. But they certainly don't have a monopoly on it. So I look for those people, I gravitate towards those people, but I agree that there's a correlation there.
Yeah, for sure correlation. And this question, is it a selection bias into the PhD or is there actually some causal effect of the PhD training, right? And I'm sure it's a mix of both, but how big is it?
Yeah, we could do an RD on that probably.
Yeah, well, it's a debate I've had with many people and it's hard to disentangle. So, working in tech and having been exposed to different disciplines, what do you find is the key difference, if there is one, in the skill set of an economist versus some of these other technical disciplines?
That's interesting. I would love to hear your thoughts on this too. I think, again, this is not something that economists have a monopoly on, but it's something they've been doing for a long time. So you get used to doing this. It's this idea of thinking about the process underlying the data that we see, and then thinking, how would I back out the core mechanisms or like the primitives explaining it? So the core example is like demand and supply curves. If you looked at data on prices and quantities in the world, you'd see a mess, right? Maybe you'd see it would be upward sloping, maybe it would be complete noise. It doesn't tell you much about what's going on. And I think the reason that people start with demand and supply curves is because, first of all, they're everywhere, but also it's a really cool example of coming up with components that make sense individually and interact in a way where you couldn't obviously understand what's going on until you backed up into something you can't necessarily see and then understood it as components from something you can't see moving to produce something you can. So that kind of grounding of being like, what's going on under the hood that I might not see, but it produces the data that I do see, and then trying to back out what's going on under the hood, I think is something economists do a lot. And again, it's not only economists, like signal processing engineers do this, because that's kind of like this pops up a lot. But the fact that we have so much trouble piecing out the like components that come into an equilibrium system that is the economy means we get a lot of practice in this. I think it also segues into stats and causality pretty easily. Like, I know a lot of machine learning and AI people, and they're awesome. They're awesome engineers, and they're awesome at prediction, and they're awesome at statistics. I think what I notice is economists are the ones in the room often asking what we should be measuring in the first place. Like, what kind of theory does that measurement rule out? So in price and quantity example, like you can't just predict prices and quantities and assume you have a demand curve because there's a whole bunch of stuff going on under the hood. You have to think, what is the underlying relationship I'm trying to capture, and does the measurement I'm looking at actually capture that relationship? So this comes up all the time. There was one graph I love that we made, which is fast shipping products sell more, and everyone knows that. But if you went into the data and looked at things that ship fast and how much they sell, you're going to get an overestimate because the things that sell a lot are pre-positioned in warehouses near customers, so they ship fast. And so the causal mechanism that you want is only one direction, but actually there's causality in multiple directions. And so it's the kind of thing of like, what's the question we're asking and why is the measurement we get deviating from that question that I'm just kind of poking on all the time. I think economists are the only ones who do that, but we're really used to doing that.
How much of this kind of thinking, because all of these things you mentioned, right, they require detailed and careful thinking about the problem. Like it sounds like it's not for lazy people to question these kinds of things.
That's a good way to put it. You have to think it's fun to question things. I think this is also, my in-laws make fun of me for this. Like if you say some statement about the world, I'll often be like, why do you think that's true? Or like out of genuine curiosity. I'm not trying to like nail somebody. It's just to like, what assumptions form the basis of what you believe about the world? And digging into those assumptions is interesting. So you kind of have to get a kick out of being like, what's actually going on under the hood and what could I be wrong about in order to enjoy that process, in order to do it enough that you get enough practice doing it. So, I wouldn't just say lazy people, but I do think you have to get a kick out of it because it's hard and you won't want to do it unless you enjoy it.
Yeah. And I think it really challenges your own confirmation bias, right? To do it properly. So, for example, I'm a big health and fitness nerd, and I listen to podcasts and read about all sorts of things, right? And it's very easy to fall into a confirmation bias where you're like, oh, I believe the keto diet is good, right? And then you can look for so-called scientific evidence, right? And then I think what's interesting is the question of, one, is a finding causal or not? But the other thing is, what's the magnitude of the finding, right? So like statistical versus economic significance. So sometimes you listen to, say, some health podcast where they talk about the scientific study and they found a statistically significant effect of some supplement, right? But then it's like, how big is the magnitude? Is it zero? And how big is it in the scope of all things health related that someone should be doing, right?
Yeah, and if you check enough things with enough data, you'll get anything you want to be statistically significant.
Yeah, and I think also placing it in the context of the whole, right? Because say the biology or the economy are complex systems. So how much certainty can you possibly have about something, right? Like we know some big things, but then when we go to these detailed things, even if there is a study that's statistically significant, what's the weight of the evidence for that?
And does it matter? I often get into a conversation. So nature versus nurture is a common one. People will be like, is this particular thing that someone does because of how they were raised or because of genetics? And everyone will be like, well, it must be a little bit of both, as if that solves the conversation. But it doesn't. Like, if it's 5% of one and 95% of the other, you need to know that. You need to it's not that everything is 50-50 if it's a little bit of both. So knowing what's important and what's not important, I think is critical. I remember my PhD advisor said, we don't care about the numbers that come out of a study. We care about whether it's big, small, or medium. I feel like that's kind of true in a lot of the world. Like, it doesn't matter if it's statistically significant. It matters if it matters.
And so going back to the things that economists specialized in, you talked about thinking about the underlying mechanisms. Another thing I find interesting when I speak with engineers and people who come from a more operations oriented background is that economists think more about who is behaving how and why when we think about customers, for example. Is that also your experience?
I think that's true. Yeah, there's a couple maybe habit differences that I think come out when you start practicing sort of statistics in industry. I think one of them is this who is behaving how and why, which is to say, we call it heterogeneity. So like a lot of papers I read will say, imagine the effect is 10, right? We do something and it's $10. The effect is never 10 because if you take different people, they'll respond to things very differently. And so a lot of modern econometrics is really about if everyone's behaving in a slightly different way, what's a number you can get that sort of captures whether this thing is important or not? Like, are you taking the average of people's causal effects? Are you taking some kind of weird weighting you don't understand? Are you taking an effect for this group of people, but it's different from the effect for this group of people? So I think you're right that who is responding and how people respond differently is more common in economics. Like, I never take a number super literally. I think about what is this capturing among the various heterogeneous responses in the world. I think that actually gets to a deeper point, though, which is especially applied sort of labor public econometricians. I think any model that you give me of the world is probably not true in fundamental ways. And in particular, there's a lot of statistics and operations people, especially in physical sciences, physicists, who can say this thing is distributed log normally, or this thing is distributed according to some Gaussian distribution, and I'm going to make some maximum likelihood estimate, some econometric estimator, assuming that my errors are normally distributed. And I think economists in general really avoid that because people are so complicated that you can't just rely on rules about things like error terms. So the Gaussian distribution was created because Gauss was looking through a telescope and derived that when you have lots of little nicks and scratches on your telescope, the error in your measurements starts to look like a normal distribution, which is like a physical law that's approximate and very interesting. But humans are super, super messy. So like, it's very rare that I see a distribution that clearly fits a normal or a Gaussian or a chi-squared. unless we start relying on big properties like the central limit theorem that start to hold in big samples for a given person. Like I really don't think I know much about you. And I don't think I really can take any distribution literally. And so I think there is a difference that I run into where people from physical sciences really want to model out exactly how a given particle or item works. And I think economists have learned through hard experience that that's really hard to do with humans. And so we focus much more on like, is this thing big or small? And are we missing pockets of the world where it's big or small? Does that make sense?
Yeah. Do you think, because of course the economist's role is very as well established in big tech companies like Amazon and Wayfair and so on. Do you think economists are appreciated enough in smaller companies or in startup, or isn't there really a place for an economist in, say, an early stage startup?
I would love to say that there is a place for an economist in early stage startups. I think it's less obvious depending on the startup. And so I don't think it's surprising that they're not the first people a startup would hire. And I think in most cases, they shouldn't be. I do know people who work as fractional economists at startups. So they'll help you design a pricing system and they'll help you understand cannibalization of the different products that you sell with one another. Like economists can be very useful, but I do think to make full use of an economist, you need to have a lot of scale. You need to have enough people that these sort of rules kick in and you don't think you're taking everything literally. And I think there are just fewer of them. Most economists, not all, but most economists are a little bit less of builders and a little bit more of thinkers. I don't mean that in a good or bad way, but I think a lot of ML Platts data scientists are also kind of want to be engineers on the side. Some economists want to be engineers on the side, but they're often the ones in the room being like, did you think about it this way? And that's not the first thing you do when your company's on fire. It's something you want to do when your company's big enough to start optimizing. Does that make sense?
Yeah, well, and you need to have the data in a warehouse and some compute infrastructure before you start building models.
I do think there's a small subset of economists that I aspire to be in, but it's hard to be both, who are economists at heart, but engineers on a lot of their day-to-day practice. You can get experience at small to medium companies. So they can build something up and then they can start asking the questions of like, what should we be optimizing? How should we be doing this? I think that's an increasingly common role as economists and data scientists get closer together and the distinction becomes less clear. But I still think there's specialization and comparative advantage. If I was starting a startup, most of the time an economist wouldn't be the first person I hire, but I think once you get to medium scale, they can be really useful.
Yeah, no, for sure. I actually really enjoyed the data engineering part. My first job was at a company where I did a lot of data engineering.
It's satisfying because you build something, you can see that it worked.
Yeah, it's very satisfying. So I think I'm an economist but an engineer at heart almost.
Yeah. I often ask students if they're more of builders or more of, I don't want to say thinkers because it takes thinking to build something, but do you get a kick out of watching something come to life and confirming that it works? Or do you get a kick out of understanding some kind of underlying mechanism or truth, even if you're not positive that that's how it works in practice? Some people love building and love seeing that thing come to life. Those people, in my experience, love being ML ops people and engineers. Some people really get a kick out of understanding something in a way they didn't understand it before. And they like building or they like seeing things come together, but it's not the thing that primarily drives them. I think economists often fall into that camp.
So you mentioned students. I forget, do you teach or do you interact with students regularly in some way?
I guest lecture quite a bit. So I'm not like you. I don't have a course of my own, but a couple times a year will sort of run into students and then I sort of just mentor or advise students.
Are they undergrads?
Master students or undergrads or PhD students thinking about getting into tech.
I'm curious, what's your impression of undergrad students or master students?
It's a very broad question. Can you can you be a little more specific about the question?
Yeah, well, I can tell you what kind of prompts the question. I find that they want to take data and throw it into a model. And they're not trained to think about what they're going to do, why they're going to do, what's in the data, look at all the details. They just want to do something on a very superficial level.
I think that gets into the distinction between being a builder or being someone who gets a kick out of really understanding things again. I think a lot of people in data science right now come in to be builders, and given all the tooling, it's not easy to be a builder. That's not to say that's not to diminish the difficulty of building a good ML model and doing it right. But it's easy to get started and to get quick satisfaction out of that. So I think we see a lot of sort of resumes from junior people coming in where it's pretty clear that they are good coders, that they have a lot of experience with the models, that they understand like the core version of models in each of the key categories. Like they get trees and unsupervised learning, and more of them are getting LLMs, and they understand the basics of causal inference, and that's awesome. I think the thing you spoke to earlier is really important here, though, which is if we need to whip up a package and build a little, a convolutional neural net, we can figure that out. Like that's something that you can pick up with some experience. The thing that's really, really hard to find is people who have enough experience asking what question we should even be asking, or enough experience making judgment calls on what we should be measuring and why. That turns out to be much harder to find, and that's what we ask about in interviews. So it's great to learn all the packages and learn the models and learn how to code. Like that's sort of table stakes. But I will say what you referenced earlier of it's really hard to learn how to ask a good question. That turns out to be the most important and rarest thing. And I do think anyone who's sort of coming through undergrad or coming into a master's program, they would be well suited to do the hard work of trying to understand what they're doing and why, more so than adding packages to their resume. Does that make sense?
Yeah, yeah. And then the other thing is, if you have something on your resume, you have to be able to explain what it is.
That's true. My boss says the only thing faster than the speed of light is the rate at which people are becoming experts at LLMs on their resume.
Okay, that is really funny. When you interview people, what do you look for? Because I teach undergrad students, and of course, the hurdle from getting from no job experience to a job experience is the biggest one. And they always wonder, what should I be doing? How do I stand out? What do I do in interviews?
The basics of models are table stakes. Like if you say, I know how a gradient boosted tree works, like you should be able to explain it. That's absolutely true. I think the thing we look for as soon as we pass that bar, and to be fair, a lot of people pass that bar of basically understanding those things, is structured thinking is number one. So if I ask you a question that you've never seen before, you don't have to get it right. This is a common misconception about interviews, is you don't have to absolutely nail the question. What I'm usually looking for is, are you asking the right follow-up questions to understand the core problem that we have and the key mechanisms around it, and then progressing towards one or two kinds of solutions and making your judgment calls clear along the way? You can get the wrong answer, but do it the right way and absolutely nail an interview. So I think that is one common misconception, that it's not just that you say, I know how this model works. It's that you say, here's a strange problem I've never seen before. Here's how I would start to think about it. Here's why I would pick this kind of model to answer this kind of problem. That sort of shows a bigger picture understanding that's really valuable. The second thing I would say is, you alluded to this, knowing what you don't know is really valuable. So one of the worst things I've seen in an interview is someone who is confidently wrong. If you clearly have good breadth in general, and I push onto a direction that you're not super familiar with, and you say, I'm not super familiar with this, but this is kind of how I think about it, and here's how I'd look for more, that's often a perfectly fine answer, because in reality, you can't know everything. And so who do we really want to work with? We really want to work with someone who does some of the hard work of structuring things and making judgment calls, and then knows where to look when they don't know something. You do not want to look for someone who grabs whatever package they heard was cool and throws it at a problem, whether it's suitable or not, or someone who assumes that they're right without really thinking about it.
I really like what you said about asking questions. Because now that I think about it, there's so many people you interview where you ask them a question and then they start answering. But it really should be a rule. You should ask at least 3 follow-up questions about the details of the problem.
I will say that the higher up you get in interviews, the vaguer they are. So I don't have a rule if it has to be 3 or 1 or 5, but I do think it should be clear that you understand something, and if you don't understand something, you'll ask about it. I've seen interviews where, like, the interviewer might say something incorrect, in order to see if you will correct them in a good way, in a productive way. And like, so you really want to be honest and think about it. You can't trick people into thinking that you know more than you do. Sort of the best way to look good in the long run is to be good, I think.
Well, yeah, that's for sure. That's for sure. And I think showing that you're a person who can be trusted with working independently on ambiguous problems. Because that's really the biggest thing. Am I hiring someone who I'll have to babysit and verify all of their work? Then it kind of defeats the purpose.
Yeah, and like your managers are people too. So I think there's some sense of, oh, the managers must know everything. They don't know everything. They're learning as they go, and having someone, even if they're more junior, even if you sort of walk them more through how things work in practice and mentor them, like they can teach you a lot. I learn a lot from my directs. And I think a lot of the time my initial judgment was well founded but wrong. And it's a process that's back and forth of us learning as a team how to go in the right direction. So you want to be a team member. You're not just sort of taking orders.
Yeah. And so an interesting question, I think, once you advance in your career is you will be working on problems where you have to set the direction and they'll be increasingly ambiguous. And sometimes you won't have a manager who is an expert in the area, or maybe there will be no manager at the moment, right? And you have to lead it. How do you think about when you're more senior and you're in a situation where you have a problem where you don't know the solution? It's not really obvious.
I will answer your question with a statement that might not seem like an answer, but it is. The best compliment I think you can get as an economist PhD student, but also as a data scientist in tech, is that's a great question, right? If someone says that's a great question, you should take it as a huge compliment because to me, most of the work in life, but especially in data science and ambiguous problems, is did you just ask the right question? Because if you're asking the right question and you know how to basically find an answer to questions that you ask, then you'll get in the right direction. So I absolutely agree with you that like a lot of these things are ambiguous. It's like, what should we be doing? The guidance I usually give to junior team members is imagine that your manager wasn't there. Like if I didn't exist, what would you do? And default down that path. And like, you'll be wrong sometimes. That's perfectly fine. I'm wrong sometimes too. But try to use judgment and think if I were alone trying to do something, trying to make a business successful, what would I do? And then just report that up, like make that transparent so we can negotiate it or, I can move you if it's in the wrong direction. But that process of what should we be doing? What's the right question to ask here? Where should we move? I think it's both really hard, but it's also, again, what distinguishes people who can run a lot of packages from people who like really add value in a unique way.
Yeah. And I think the perspective of if this were my business, what would I want to know maybe is a good guideline.
Yeah, I think that's a very good guideline. You'll be in rooms with execs eventually. I was in one of these rooms yesterday. We're in a room with a bunch of C-suite people, and they have no idea they don't know statistics because they don't have to. Like, so you have to really think, what do these people care about? And how does that link to the paper I wrote last week? And there are like 7 or 8 steps between there. But ideally, you can link them all together. So that's something that takes decades of practice. But I do think it's fun. It helps you understand why we're doing what we're doing. But it's also not easy. So I think starting from there and then building up your skill set around it is a really good piece of advice.
And then the other one is, if possible, link your insights to some sort of dollar value.
If you can. This is something I always go back and forth on this because I think you will see resumes where someone has just taken whatever dollar value they saw was highest and put it on there. And it can be sort of like falsely appealing. How do you know that that was the dollar value? Like even just measuring those things is sometimes very hard. So I agree that being concrete is helpful. Putting dollar values on your resumes is helpful. I do think if you did the wrong thing and put a large dollar value next to that, like it doesn't actually help. If anything, it hurts just because at its core, we're less interested in the number, which is easy to, I don't want to say fake, but it's easy to sort of like say we think we made $20 million, but it's really hard to verify. So let's just put it on our resume. It's really hard to say we made decisions based on these success metrics in order to push the business forward. And we thought it was successful and this is what we did next. And so I agree with you, put dollar numbers where you can, but I also think you can overemphasize it relative to just the judgment calls you made and the experience you have.
Well, and even before you get to the resume stage, how is your input measured in the company, right? So you have annual performance reviews. Well, it's going to depend on, I think, the culture of the company and the management. But sometimes as an economist, if we compare ourselves to someone who's, I don't know, programming some sort of optimization code where if you make the code faster, right, it saves X seconds per iteration and you can just convert it to savings in compute cost or something like that. It feels like we're competing almost at an unfair advantage sometimes, or disadvantage, because it's harder, much harder sometimes to make these, I guess, calculations for the things we do.
I think you hit on a really great point, which I've been struggling with. The more I'm around, the more I realize how important this is. Of measuring your own success is very hard, especially if you're in environments like we talked about, where you don't always know if what you did was right. This is true in a lot of business contexts. It's less true in optimization or A/B testable environments. But sometimes we're building a model of how people respond. Or, for example, right now I'm working on a lot of long-term value work. Right? If we damage your product, do we lose you forever, or do you actually come back pretty fast? I've jokingly asked. They will not let me experiment on that. I'm not allowed to go out around with a hammer into the warehouse and smash things. So you don't really have a ground truth. So what do you do instead? If you can get dollar values, that's fantastic. But there are other metrics to show that you're on the right track. And so I think something else that people maybe underrate coming into the industry is transparency and trust, and bringing stakeholders along for the ride so that they want to use this thing is really important. If you sell snake oil for too long, like, you will be found out. There's some sense of like you have to really do good work in order for smart people to over time trust you and that reputation to build. But I do think if you can't get a dollar value, are people using this? Do they trust you? If a new scientist comes into the organization and pokes around, do they think you're doing good work? Like, those are substitutes to sort of show that you're pushing the business onto the right track, even in environments where you can't necessarily A/B test to get a dollar value straight out.
And I think this points to a broader question in data science in general, right? You hire someone, they sit and write code that outputs something. In more cases than not, no one else is looking at that code, right?
So I think that's a great question. I think another benefit of being in a medium-sized place, it could be a huge place, but at least having a couple other people around you and a couple data science groups maybe, is that we should be holding each other accountable. We should be doing code reviews in your team at least, but also we should be trading notes, right? We should be gaining trust in each other over time, because we're going to have to rely on each other to put the various pieces of this algorithm together and to make this company successful. So I absolutely agree that like very few people can read your code if you set up an organization like that. At the same time, the healthiest organizations I know of have a small community of scientists who consider themselves to be honest scientists. Like, they're business people, they're trying to add value, but they care that they're pushing us in the right direction and not just looking good. That to me is sort of a sign of a healthy organization.
Yeah, I agree.
I also think that's, like you said, it's correlated with PhDs, but it's not, you don't have to be a PhD to want to do that. I think part of the reason PhDs are becoming more common is because we take inherent pride based on our past in sort of feeling like scientists and being scientists. And having that ethos in an organization, I think, keeps us jointly honest.
I also think, right, it's a very good signaling mechanism. I don't think a master's or an undergrad degree is a strong signaling mechanism of anything. But if you get someone with a, not to say that there aren't many extremely brilliant people with undergrads and master's degrees, right? But if you get someone who has a PhD in physics from Harvard and is inclined to work in the industry, right, then they're probably very good at what they're doing.
You can take for granted that they're smart and determined.
Yeah.
Right. I think you can't necessarily take for granted that they're good communicators. Like, you still have to vet them, but I agree with you. Signaling is real. But I have a follow-up question that I get this question. I think it's hard. If someone really wants to be a top-tier data scientist, but they aren't inherently interested in a PhD, should they get a PhD?
Yeah, that's a good question. It's a big investment in terms of time and foregone income. On the other hand, it's an interesting lifestyle because, I mean, there's a lot of freedom in terms of time during your PhD. I at least for me, I thought it was a fantastic way to spend my time. But so that's a good question.
I don't think there's a one-size-fits-all answer. I just think it is a tough question.
I agree with you. I think if you get a PhD in a technical discipline from a high quality institution, and you know from the outset of your PhD that you are going to go into the industry, then you can tailor your PhD so much to set yourself up to get an amazing job somewhere, right? Like if you knew I want to be a computer science researcher at some of these AI companies, you could get into a good PhD, you could probably set yourself up for some really interesting jobs. I think one question is, we know that there are some jobs where you need a PhD, for sure. If you want to be an LLM researcher at OpenAI, unless you are some sort of extremely brilliant person who won some kind of Olympiad in your undergrad, you probably almost certainly need a PhD.
Is that for signaling or for learning? I think it's probably both. You need dedicated time to really get into be the top tier of something. You need like years of just doing that thing. But I do think there's probably a signaling component as well.
Oh yeah, I'm sure there's a signaling component. But some of these positions, they look for people with a track record of publications in a specific field. And that's just hard to do without a PhD. I'm not saying it's impossible.
I agree. I also think this goes back to the, are you a builder or are you a thinker? Like, not mutually exclusive, but I think people who do PhDs tend to really want to spend years thinking really hard about something to understand it. You have to really like that topic. That is correlated with sort of being a data scientist who says, I have this super ambiguous topic and I want to go learn about it. So I think there's a little bit of that question. I think when people ask me, should I get a PhD? I often start with that question. I think it would be hard to do a PhD if you really just wanted to be a software engineer and you were stuck for 4 years thinking about something you didn't care about. But I think if you do care about something and you get that signal as an outcome, it's probably a good idea.
Yeah, that's probably a good distinction. And I think to clarify, I think if you are determined to be really good at something, I mean, you don't really even need a college degree, right?
But you do need signals. I think signaling is, I will say, as someone who's now hiring junior people, it's very hard to distinguish people through hundreds of resumes that sort of look the same. And that's not to be discouraging. It's just to say that signals are very useful. And so investing in signals is helpful. I think that's a little bit underrated too.
But then suppose you don't have a college degree, right? Which is a signal. Then the question is, how good of a signal is that? Which is another discussion. Then if you don't have a college degree, you need to create your own signal. And so how do you do that? In my mind, you need to build something, right? You need to do something. And something that's tangible. So for example, I would look for a GitHub repository that's well documented, well built. And if someone came through the funnel, now I know there's a screening in the funnels, right? But suppose you can get through that funnel with just a high school degree. And you come to me with a high school degree and a really well-made repository of well-documented code and you can speak coherently about it. I'm probably more impressed than if you had a degree, because it means you did all of this on your own.
Totally. I do think there are some of the most impressive people I've ever met are ones who didn't have the typical path and did it anyways, and therefore have demonstrated how impressive they are. I do think there's sort of maybe a sad reality that people's attention and time is very limited, and that's maybe the right strategic thing to think about. So why is networking helpful? I think there's a myth that networking is helpful because everyone's sort of patting each other on the back and wants to help their buddies out. And maybe that's a little bit true, but I actually think the primary reason networking is helpful is because if I get hundreds of resumes, it's as a human who needs to hire somebody who's stressed about it at their own job, it's very hard to know who to trust. And if you have someone you already trust who says you can trust this other person, who can basically use that trust and pay it forward, that's very useful for as a manager who doesn't want to take a ton of risk on somebody, which is just to say, like, quick signals, I think, are extremely valuable to get into the door. I completely agree that conditional on getting in the door, I'm already interviewing you that hour. Like, I don't care where you went to school once you're in that door for that hour, if you impress me. I just think there's a barrier to entry that is just because of attention, because humans are humans and have limited time. That explains a lot of why networking is helpful, why going to a good school is helpful, while having quick signals is really helpful. It's not because you can't be amazingly good. It's because the people on the other side of that hiring pipeline are very busy, and the quicker they can determine that you're not a big risk, the higher chance you have to get into the door. And once you're in the door, it's just like, much more of a meritocracy.
That's true. Do you think with disciplines like data science, where you can learn so much online on your own, there's going to be a shift towards different types of signaling devices?
So I think I would love to say yes, but I think my honest answer is I don't see how it happens in the near future because of that time constraint. I think the idea of people aren't going to go to elite colleges anymore because you can learn everything online, that could be true, and it's awesome for the world that we have that kind of knowledge. But I think if you're somebody who wants to get a first job in an elite place, that manager is still going to look for quick signals because that manager is stressed out. And so I guess I have not seen a super strong replacement for that process. I think there are things people that are trying, which is great. So there's like certifications you can get. You can win a Kaggle competition. Like there are ways that are coming up that are great, and I'd be impressed by those, and they're the quick signal you might need. I don't think they're as common or commonly certified and trusted yet. Maybe in 20 years they will be. I think that would be a very cool outcome. I don't think it's going to happen in the next 5 or 10 years, so I wouldn't bet on it relative to some of the other quicker signals.
Yeah, no, that makes sense. So I think thinking a little bit broader than just data science, do you find that this causal training that we have, and you alluded to it a bit earlier too, that it's useful in everyday life?
That's a great question. I think, you asked me this question once and I didn't know how to answer it first. I think the answer is yes, but I was thinking about how. There's something in economics that we call identification, which is this core idea of if there are two theories about the world and you see data that came out in the real world, can you actually distinguish between the theories? So this took me a long time to understand because it's hidden in technical jargon, but basically like you might think the answer is this thing doesn't matter, or you might think the answer is this thing is a huge effect. And if you run an experiment, the question of are you identified really means could you disprove one over the other in the data that you saw? That concept, I think, kind of shows up everywhere. So like we don't see the real world. In my little brain, in this like box, I don't see the real world. I only see noisy data that comes out of it. And I think thinking that there's a primitive in the real world that I might not be attuned to, and I'm just trying to infer what that might be is really useful. So like concrete example, when I meet people at like a party and they're kind of standoffish, I think my wife has a tendency to think they must not like me. And if you think of it as an identification, like I just have a noisy signal, it's consistent with them not liking me, but it's also consistent with them just being shy or just like not quite vibing in the right way. And some of my best friends have come about because I couldn't identify whether they didn't like me or not, because there's another hypothesis that was perfectly consistent with the data. And so I assumed that they might not hate me, and I like kept hanging out with them. I like invited them to something, and then it turns out that that other hypothesis was true. So I do think I sometimes call myself a giant online bandit, meaning I like develop a theory, but I only have noisy data. Then I kind of do semi-random things in order to see if that theory is true, so I can identify what the world is like. And then I sort of re-optimize and rinse and repeat. I think that's a super powerful way to live. It's also kind of fun because it gives you permission to experiment. I've always done something this way. I've always studied for a test this way. I've always been risk averse at work. Maybe I should be a little more risk positive in a local sense. Just do things a little bit differently next time than you did the last time in order to see what works. Because, it's kind of scary, but like, I don't know reality. I only have these weird noisy signals of my interpretation of reality. And sometimes you actually can't identify one theory from the other. Does that make sense?
Yeah, it makes perfect sense. And you're talking about experimenting here, and that's one area of identifying the causal mechanism. The other situation is if you're in an observational setting, as we call it, where it means you can't experiment, you have some data, and you need to make some kind of inference or decision about what's the causality of things without the ability to experiment. And it's a lot about questioning mechanisms, I think, and how data is presented to be related. And I find that this is really useful, right? Like, how often do you open the newspaper? I guess that sounded very old-fashioned. You open the website and you see some sort of information presented as being causal, right? Like, the government did this and this caused this, or this policy caused something else. And I think when you have this questioning mindset about causality, you're much more skeptical to believe information that's delivered to you by so-called experts or whoever it is.
We used to have a saying in my 20s. It's a common saying that if more than half of the party is economists, then the party is ruined. And we'd like actually keep track. Like when people would come in, we'd have a tally of how many of them had economic training. Because we keep doing this, like economists are very much like, do you actually think that's true? Like, which is annoying, but really interesting. Because if you're around more economists who are also interested in asking if it's true, it's pretty fun. So, but I totally agree. There are a few things where another saying I've heard is once you see price discrimination, you can't unsee it. So things like I don't buy the second cheapest bottle of wine because it's strategically priced because people don't want to buy the cheapest bottle of wine, so the markup's higher. Like there's like weird little things like that are just once you see that soda at a movie theater is expensive because they're trying to find out who's willing to pay for it, you like feel like you don't want to buy it anymore. There's like weird daily things like that. I mostly buy index funds because I think efficient market hypothesis is probably mostly true. The idea of use your comparative advantage, even if it's not an absolute advantage. Like I play bass. I'm not that good at bass, but I'm better at bass than other people are at other instruments. So I get to play with better people. Like there's little economic tricks that you see a lot when you start to study this stuff that just apply to your daily life as well.
I guess we have advertised this questioning mindset of economists a lot. Now I'm asking myself, do you think economists are more open to changing their mind than, I guess, the average person, whatever that means? Because hopefully, if you have this mindset of questioning what really is true and is this data presented in this way, you would be more open to changing a firmly held opinion if the right evidence were presented to you.
I almost don't want to say this because I don't want to think that economists are really good at this, but I do think it's correlated. Like, I don't know if it's because of the economics training, but I do think the economists I know tend to be pretty open-minded because they don't take pride necessarily in their conclusions. They take pride in how they got to the conclusion. And so I think that's another thing that I think about a lot is I know a lot of people with strongly held beliefs. The economists I know, and a lot of the data scientists I know as well, they take pride in the fact that they thought about something and they tried to understand something before they jumped to a conclusion. And they don't really care if they were wrong before or not. They care if they're on the right track now. I do think that's a really fun mentality to have because it just means that I feel a little less defensive about a lot of particular beliefs that I might have once had because the point is that I'm learning and the way you learn is important. I will say, I think there are some things economists are kind of wrong about, or I should say they kind of ignore. So the more I learn about other stats, I think there are other fields that have certain things right. We have a tendency, technically speaking, like we have a tendency to kitchen sink controls, and we don't think about things like M bias. Like a lot of economists don't draw enough direct acyclical graphs, in my opinion. I think we have too much faith in asymptotics. There's some work coming out. Alvin Young is doing a lot of this, basically being like, if the central limit theorem hasn't kicked in nearly as fast as you think it is, so a lot of the just quick assumptions that we make are actually kind of far off. We need to worry more about leverage and more about subsampling. I think we have limited comfort with some sort of key Bayesian ideas, regardless of whether you're a hardcore Bayesian. So I definitely don't want to say that economists have everything right. I think especially certain directions of academic economists have missed some things when you get into applied tech land. But I do think, in general, the people I run into who have this kind of training or similar training care about being open-minded. They take pride in trying to figure out an answer through a process. And that's kind of satisfying.
You mentioned kitchen sinking controls. Can you give an example of that to people who might not know what that would mean?
Yes, absolutely. So like, I was thinking about an example recently, actually. We're trying to figure out whether if you order something on Wayfair, it causes you to come back and order more because you got a good experience. And the problem there is that some people are loyal Wayfair customers, so they order today and then they order next week, and it's just because they're loyal. It's not because the first order caused the second order. And so we're trying to figure out, how do you find people? How do you adjust for that? Like, how do you find proxies to loyalty? And this is a little bit complicated. I think it does illustrate the issue that we run into. One thing you can do to proxy for loyalty is condition on clicks, like time on the site, for example. So I spent a lot of time on the site today. It might mean I'm a loyal customer. And then later in the day, I bought something. And then did I come back next week? That seems like a kind of reasonable thing to do. You're not conditioning on an outcome. You're not sort of breaking the traditional rules that a lot of econometricians talk about. But for example, what if there was a sale today? If there was a sale today, then it turns out that you might have a bunch of people who clicked around because of the sale and ordered today because of the sale. The fact that it was a sale today and you ordered today means that among people who clicked around, the people who ordered today aren't loyal, so they didn't actually come back. And if you clicked around today but you didn't order, it probably means you're not here for the sale, so you're probably a loyal customer. And so if you didn't order a conditional on a click, then you will order later. And so what I've just described is that conditioning on something, conditioning on whether you're clicking around and spending a lot of time on the site in this particular scenario, has created a completely synthetic correlation between these two things that didn't exist before. So a lot of economists will say control for a bunch of stuff because you're controlling for confounders. But if you really stop and think about the underlying DAGs, like the underlying causality, you can sometimes over control for things and end up shooting yourself in the foot. It's a hard question to solve, but I do think I was never trained to worry about that. And now that I've run into more people from computer science or epi backgrounds or operations research backgrounds, there are things like that where you're like, maybe we should be worrying about this. Right? Maybe we should be worrying about when central limit theorem kicks in. Maybe we should be worrying about what my priors actually are more than I was trained back in the day.
I agree, because I think controlling for quote unquote things or a lot of things, it can give you a false sense of security. Because you are going to get a number from your regression, right? And you can say, I put a lot of controls in them, and you can write the whole paper on how those controls mitigate all sorts of biases, right? But I think simulating data is really illuminating.
I agree. And I also think this is something where if you don't think about it too hard, it almost feels like post lassos and double machine learning and a lot of the new stuff helps you pick your controls. And that's kind of true, like in a very limited sense. If you don't know the functional form, you can use these tools to get more flexible specifications, but it doesn't solve the problem that I just said, right? If the problem I just said will be a problem regardless of what tool you're using to select your controls. And so it really does require you to sit down and think and weigh some trade-offs and decide whether it's better to control for this thing or not. Usually with simulations, but with sometimes it's a judgment call.
It is, yeah. I guess the solution is what you just said. You need to think about it, and you need to think about who the customers are, right? Put yourself in their shoes.
Is it worse to be an overestimate or an underestimate is another way we think about this, right? My job is not necessarily to get the best estimate in every case. It's to push the business in the right direction. And usually that means getting the best estimate we can. But if you have an arbitrary trade-off where you say, I'm not sure if A or B is better, sometimes you want to say it's better to shade down or it's better to shade up because of this particular situation and the risk we're facing as a business. We'll push the business in a better direction by providing this number. It doesn't feel as scientific or satisfying because you don't know that you were right. You can't confirm that you should have controlled for that thing. But it is sort of a necessary part of the job as the expert making judgment calls to push us in the right direction. I have another example too. I think another example of like things that economists, PhDs are too overconfident in is standard errors over modeling uncertainty. So running into this a lot where if I build a model with all these controls, and even if I use like lassos for controls, like you fix some kind of model structure and then you build standard errors around it. And that standard error is really just capturing if this model were true, or this modeling structure at least were true, then when you resampled over and over again, you get this kind of deviation in the model. That's often not the thing I'm worried about. Like the reason I'm uncertain about this number isn't because of repeated sampling variation. It's because I don't know if the assumptions under my model were reasonable enough to really rely on this number, or like to the extent that we should rely on this number, right? That's what I really want to say when I say, are we certain about this number? And so I do think it's great to care about inference. I think everyone should care about inference, but I think you should also know the limitations that like statistical sampling inference is usually only a piece of the puzzle and sometimes not even the biggest piece when you're trying to communicate uncertainty in your conclusions.
Yeah. And this is why I think model risk should be at the forefront of any kind of presentation of results, right?
Yes, but it's not quantifiable. And so it's really hard. It's actually quite a hard thing to communicate in my experience.
I think it's very hard, but I think you still should do it. For example, going back to the interview example, if I ask someone about a hypothetical project in an interview, if they could talk to me about model risk and the choices they're making and what implications the choice of the model might have for the inherent risk of using the outcome of that model, I would be super impressed.
I think it gets back to maybe looping it all the way back around, right? The fun thing about this job is that we're trying to say, I only have anecdotes. I'm only in my brain. Like any one person, even the CEO is only in their brain and knows the people they know. How are we going to get a big picture on something that's going on in a way that we can identify what's probably really true or not? That requires a lot of being humble about how we're trying to do this and what we're trying to measure, and do we actually know that this is what we're trying to measure, and how do we measure success and all of that. And a lot of that process of figuring out, do we think we're capturing the basic right conclusion here? A lot of that is like knowing your statistics and getting the right standard errors, but a lot of it isn't. A lot of it is like the more qualitative but structured thinking you can do along the way to make sure that you're not tricking yourself into being more certain than you are.
So we have talked a lot about thinking about the problems, thinking about the data, things that don't sound super, I guess, fancy in terms of the degree of technicality and coding. If you were to give advice to students, whether they're PhD students or undergrad students, do you think they should be focusing on programming LLMs or, all of these neural networks, I don't know, MLOps? Or does it sound like this more traditional economics toolkit is still the thing they should be focusing on?
I think in order to have table stakes in the industry, you'll want to know the basics of how this model works. Like these various models that we're talking about, you'll want to know the basics. You'll want to be a decent coder. You'll want to be able to know the strengths and weaknesses of each tool. But on the margin, once you're at that point, once you kind of know where to look to learn more, and you can speak about the various strengths of the tools, the thing that really distinguishes people who are successful, in my opinion, is the big picture thinking. And so I wouldn't discourage people from learning to code or learning how LLMs work in a basic sense to be able to talk about it for a few minutes in an interview. But I would discourage them from thinking that nailing the latest implementation is important once after you reach that point, relative to the much more important and harder work of what question are we asking and why would I even use this tool to achieve some kind of goal in a business. So, I would get to a point, but after that point, I would say the way you think about things in a structured way is much more important.
And I also think this big picture thinking is not to be confused with superficial thinking. You still need to have a very solid understanding of the foundations. You need to understand what a linear model is doing. And you need to be able to think about the big picture. But maybe you don't need to know how to build a convolutional neural network.
Something that I find very useful is like, can you explain this to someone who doesn't know statistics? One of the most fun parts of my job is that someone will take a model that I take for granted, that this is how we should do it, and say, why would you ever do it that way? Like non-economists from a totally different place, maybe they barely know stats, but they're smart. They sometimes ask the best questions because they'll say, why would you even do it that way? So like, you clustered your standard errors. What does that mean? Can you explain that in English to someone who you can draw a graph, you can walk them through it, but you can't use math and you can't take for granted that they've ever read an econometrics textbook. I think you learn a ton that way. So I guess my advice to students who are putting these pieces together, putting these tools together is, can you explain in English basically what that thing is doing and why you would use it to answer that question and not something else? I think once you've gotten to that point, you've understood the fundamentals enough. And unless you're really a specialist, you often don't need to, because we want good athletes. And once you start the job, if someone says we really have to build new fancy neural nets, if you understand the foundations, you'll know where to look. And like, you don't need that knowledge ex ante to get the job unless you're really, really a specialist.
Yeah, no, I think that's true. And I think this is really good advice about explaining. It's something you can have in your GitHub portfolio, for example. You can have a section of explanation for non-technical people. And by writing it, I'm sure you would learn a lot of new things.
Yeah, I often learn things by literally just writing memos to myself. That's also a good exercise. But in plain English, you're not allowed to use an equation. What the hell is this thing doing?
Yeah, no, definitely. Colin, is there anything else I haven't asked you about that you think I should have?
No, I think we covered a lot. I think in terms of sort of advice for students, I do think the world is competitive now and signaling is important, but I completely agree with where you're going. Like, not everyone should be an econ PhD, but I do think the core questions of why are we asking this question in the first place is more important than people realize. The best compliment you can get is that was a great question. I think that's my final thought.
I think that's a great closing thought. This was really fun, Colin. Thank you so much for coming on.
Yes, thank you for having me. I appreciate it.